Welcome to this webinar. We're pleased to have many distinguished professors who have all jointly contributed to this fantastic innovations for computer chemical engineering education. In fact, they were the joint winners of the David Himmelblau Award for innovations in computer-based chemical engineering education that recognizes an individual or group making new and novel contributions to computer aids for chemical engineering education. And as part of that, they're giving this webinar today to highlight some of the software tools they've developed and be able to share those with the community. I'll first introduce Matthew Cooper. He's an Alumni Distinguished Undergraduate Professor in the Department of Chemical and Biomolecular Engineering at NC State. After receiving a Ph.D. in Chemical Engineering from Ohio University, he served as a researcher at RTI International before joining the NC State faculty in 2011. Dr. Cooper's research interests include effective teaching, process safety decision-making skills, and best practices for online education. We also have Cheryl Bodnar. She's an associate professor at Rowan University, currently on sabbatical, specializing in game-based learning and innovation in engineering education. She has a Ph.D. in chemical engineering, focused on biomedical engineering from the University of Calgary. Her research is funded by NSF and Kern Family Foundation to emphasize pedagogical innovation, student motivation, and learning outcomes. She's recognized for her contributions, has received multiple awards, including the Silver Medal for Game Design in Higher Education, the President's Award for Excellence in Innovative Instructional Delivery. Professor Bodnar is an active member of the ASEE. Daniel Anastasio is an associate professor of chemical engineering at Rose-Hulman Institute of Technology. His research focuses on teaching methods related to safety, engineering ethics, and membrane separations, with a special focus on game-based learning and laboratory experiment design. His current work involves rapid prototyping of membrane systems for educational use. Dr. Anastasio also serves as co-director for Rose-Hulman's Project Select STEM Summer Camp for high school students. In 2023, he received the Ray W. Fine Award for Outstanding Teaching Effectiveness and Educational Scholarship from the Chemical Engineering Division of ASEE. And last but not least, Daniel Berkey is Associate Dean at the University of Connecticut with a demonstrated history of working in the higher education industry. Skilled in engineering education, curricular reform, large class management, accreditation, and chemical vapor deposition. He is a leader in education research with a pedagogical focus on the use of gamification and game-based learning in engineering classes. He has a Ph.D. in chemical engineering from MIT. So with that, we'll go ahead and turn it over to this great group, and congratulations on your award. I think you can take it away, Matt.
All right. Well, thank you very much for those kind introductions, John. We appreciate it. And so, everyone, I'm going to go ahead and bring up our presentation here. So, I'd like to welcome all of you to our presentation. We're going to be talking about contents under pressure, which we think is a really unique way to leverage computing towards teaching something that is very challenging to do in the chemical engineering classroom. So, the motivation for this work is all of the process safety incidents that we've seen over the past few decades, and they continue to this day. And I've put some examples up here. I'm sure that many of you know about all of these already, but I picked these 6 particular ones because the root cause of all of these incidents is not, say, an equipment failure or anything like that. The root cause was actually a poor decision made by humans, and this is what they call in the industrial sector human factors. And so this process safety decision making is one of the things that's difficult to teach in a classroom. And we think that we do pretty well as educators teaching things like, HAZOP analyses and management of change, all of these, knowledge process safety strategies that we know work. But when it comes to decision making, it's very difficult because, say, a management of change, that requires resources. It takes time, it takes money, it takes, people power. It's one of those things that whenever you're pressed into an actual industrial environment and you have a difficult time, weighing the incentives and disincentives toward doing that type of thing, sometimes you might make an unethical or a poor process safety decision because of all these different incentives and disincentives. And it's difficult to be able to teach and assess process safety decision making in a classroom environment because we can't really put them into the into an industrial plant and have students practice their process safety decision making there. It would just be dangerous and very expensive. So we also can't just give them like a paper type exam and expect it to get authentic responses from them either. If you've ever taken a ethics test that's on paper, you might be posed with the decision to say, make an unethical choice but have a better chance of getting a bonus, let's say, or making the ethical decision and probably not getting your bonus. But since it's all on paper, it's very clear when you're taking it that this scenario is fake. And what's more, that bonus that they're tempting you with, that is also fake. And so you don't really have that sort of realistic response. Most people will just do the ethical thing because there's no reason to say that you do the unethical thing. But what you can do instead, and this is what we're trying to do with Contents Under Pressure, is place students in a digital immersive environment that lets them feel like they're actually making these decisions in a real sort of environment that has realistic dilemmas. And so this is what they call in the ethics literature pre-authentication. So when you have a pre-authentication type environment, it's a realistic practice field where students can wrestle with these decisions. And so they kind of forget that they're taking a test or, you know, making decisions that are being monitored. They sort of forget about that fact because they're so immersed in the environment. And there are lots of different ways that you can have an authentic pre-authentication environment where you have, you can, for instance, have authentic dilemmas. So make students feel that the sort of situations that they're being placed in, make them feel like those are, you know, realistic. So that's an important thing so that they actually can kind of dive into the material. And then also have realistic incentives and disincentives. So as opposed to that paper exam, you can instead have, if a student is, for instance, trying to maximize successes, maybe points, and then minimize failures or losing points in different categories, you can give them realistic incentives and disincentives. And by them having to wrestle with all these different things, you can get much more authentic responses, and you can be able to more effectively teach and assess their process safety decision making. So I'm going to turn it over to my colleague, Dan Anastasio, who's going to talk a little bit more about how we do that with Contents Under Pressure.
Okay, thanks, Matt. Is the next slide up? There we go. Cool. I'm going to talk a little bit about sort of the context and way that Contents Under Pressure works. Contents Under Pressure is what we're calling our immersive digital environment that simulates industry decisions. We developed this virtual environment in collaboration with Filament Games, who makes a lot of educational software for different purposes. So in Contents Under Pressure, the user is going to assume the role of a senior engineer at a chemical facility, meaning that they have some people working under them, but they're also reporting to higher ups in the company. The context for some of the story too is as the students are assuming this role, they found out that maybe there are some previous safety issues at this plant. Maybe the previous position in their role left because of those safety issues. And so they have to navigate a 15 real world day narrative where they will log in once every day for about 5 minutes and make a series of decisions that sort of culminate in an impending hurricane where the decisions become much more intense. Next slide, please. Thank you. Okay, so this is what a typical day in Contents Under Pressure is going to look like. So as you log into a certain day, you're going to be presented a screen like this. Character is going to be saying something to you, and you have two decision options that you have to weigh. Throughout the game, you are trying to balance 4 different metrics. The amount of time you have left in the day, symbolized by the clock at the top, the relative safety of the plant, your personal reputation, and the production output of the plant. How much money are you making? Each one of those metrics, safety, reputation, and output, are sort of indicated by an emoticon where a happy face is good and a sad face is bad. If you're going to make a decision, you can hover over the 2 options, and we'll have a demonstration of this later. where different things are going to light up. If one of the indicators light up, that means that that decision is going to affect that meter in some way. Just like in real life, you can probably guess how it's going to change it, but it might not change it in that way. And certain elements are going to take different amounts of time. If you run out of time in a day, poor decisions impact your score more, better decisions impact your score less. So you're sort of rushing through that. If any of the meters were to hit the bottom level, the students would register a failure, which does not immediately end the game, but at the end of the game, the failures are tallied up and that has some impact on the outcome for them. Okay, when we were trying to do these scenarios, we were trying to make sure that they were realistic and relatable and relevant to industry. So we initially came up with brainstorming several ideas towards the types of decisions that are made day to day in a plant and the type that might be associated with some sort of emergency like a hurricane. We ran this past a panel of content area experts to make sure that they were in fact relatable. So we feel like the things that the students are being asked to decide between are relevant. So before we get a little more into sort of the mechanics behind content under pressure, it helps to introduce some of the characters that players are going to interact with. Their supervisors include Darwin Lopez, who he is the plant safety supervisor. He is going to pop up periodically to check in with how are things going for safety. What are some things they should be thinking about with related to safety? His personality is he tries to be relatable, but the game might describe his sense of humor as non-existent. Our next character is the boss. So the player's boss is named Wanda. She cares very much about safety, but also wants to make sure that the plant is staying profitable. So how are we going to balance staying profitable and being safe in the midst of a natural disaster? Your subordinates, you have 3 employees that report to you, and they're probably going to be the ones that you interact with most on a daily basis. The first operator is Emily Neville. She is the new operator, fresh new hire, very, very eager to prove herself, maybe a little bit ambitious, trying to manage her getting trained and also manage her expectations as part of the challenge of this game. Next is Charles Green, who's been working at the plant for a long time. He is the most experienced operator that reports to you. He's very eager to help out and sort of do what he can to be the best team player, but later in the game, there may be some reasons why he is unable to participate for a short period of time. And then finally, we have Victor Cobb, who has more experience than Emily, but is still relatively new, maybe feels a little insecure. He is managing also some mental health issues that students might need to be aware of as they are making decisions. And then finally, our supporting cast include Maria Rodriguez, the newscaster. She generally tells you what the weather forecast is going to be like. So there might be some days where it's very sunny and someone says, do you want to go out to lunch? But then as the hurricane approaches, she'll let you know that that might be a factor moving forward. And finally, to simulate some of the work-life balance in this game, which maybe doesn't show up necessarily in a paper ethics test, we've added the player's daughter character named Belle. She will call you periodically to check in, see how you're doing, ask why aren't you home, why did you miss my piano recital, to sort of add that extra element to balance out not just being safe, but also trying to manage your own life. So now that we've sort of introduced the framework of the game, I'm going to pass it off to Dan Berkey, who's going to talk about some of the theoretical underpinnings behind the game.
Thanks very much, Dan. So as you can see, the game has a lot of very interesting characters. And one of the things that we wanted to do was, not only teach students about process safety decision-making, but then also assess that. And so in order to assess how students are making these decisions, we have to think about, well, what is our theoretical framework, or what is the framework with which we're going to evaluate the kinds of decisions that students are making? So we went to the literature and looked at a variety of different theories. And one of the ones that was sort of most relevant was what's called Kohlberg's moral development theory. And Kohlberg breaks down the way people think about decision-making, ethical decision-making, and by extension, process safety decision-making into three different buckets. The first of which we're going to call pre-conventional reasoning. Pre-conventional reasoning is often how you might think that small children make decisions. It's very self-centered. It's very much concerned for personal risk and personal consequences. So I'm not going to take this candy bar from the store because I'm going to get in trouble with my parents, right? So it's very consequence-driven, very concerned with the self. The next level out from pre-conventional reasoning is what we call conventional reasoning. And this is where a lot of people make their decisions most of the time. It not only is concerned just for consequences to self, but also consequences for tangible things that I would say that are close at hand. So things like your immediate family, friends, time, money, things that have some physical context with them. And an example here might be I'm not going to do this questionable thing at work because if I lose my job, it's not just a poor consequence for me, but perhaps I can't, without a salary or income, I won't be able to support my family or pay for food or pay for the house or things like that. So it's the next sort of sphere out and how people often make decisions. The most expansive level of Kohlberg's moral development theory is what's called post-conventional reasoning. And this is more outward-facing, more altruistic, a little bit more idealistic in terms of how people make decisions, right? So this is concerned for larger, more abstract concepts such as society, people maybe you don't know or have direct connections to, concepts like justice, concepts like environment, right? Things that are larger, more nebulous, that you might not have direct impact on, but you're concerned about. And so those are sort of the three levels that Kohlberg binned decision-making into, noting that people can move back and forth between different types of decision-making in different contexts. And so what we try to do is in the decisions that we ask people to make in the game, as we were developing those, we coded all of those different decisions through iteration, through consultation with experts, coded all of the decisions that people were asked to make into these three bins. So some of the decisions, the decision prompts are pre-conventional reasoning, some are post-conventional reasoning, some are conventional reasoning. We asked some follow-up questions of participants that also are coded that way. And so looking at the game in total, we can then get a quantitative picture to a certain extent of what are the dominant ways in which students playing the game are making their decisions. So next slide, please. So Dan and Matt both showed some of the decision prompts that pop up, so we can make choices between different courses of action. After students have, or players have made a decision, we often ask them these follow-up questions, asking them, well, what did you consider in making that decision, trying to get them to be reflective about this. And so you can see here, keeping your unit running during a storm sometimes requires personal sacrifice. How relevant is this to your decision? And then students can rank that. And that gives us some additional information about how important different things or considerations are in their decision-making schema or their decision-making process. So next slide, please, Matt. And so this is just a great example of some of those reflection prompts and how they're coded then to Kohlberg's theory. So for example, pre-conventional prompt here might be balancing your personal life with work life can be difficult. How relevant is this to your decision, right? So this is very much focused on the self. How does work impact your personal life? A conventional example prompt might be giving a staff member a raise could increase their dedication to work at the plant. How relevant is this to your decision, right? So this is not concerned with yourself, but it's concerned with people you directly supervise, people that you have direct interactions with. And then an example of a post-conventional prompt would be community impacts from plant leaks can be devastating. How relevant is this to your decision? So this is not you focused on people you're working with or your family or yourself. This is looking outward to the entire community, potentially the environment. And so all these different prompts can be coded to these different Kohlbergian levels that allow us to get some insight into the dominant ways in which students make their decisions. Next slide. And I think here's where I turn it over to Matt to walk us through some live gameplay.
Yeah, thanks, Dan. So I'm going to go ahead and stop this share, and I'm going to bring up another share. So I'm going to actually share the game. So we're going to play just a little bit of the game together. So y'all can see this screen. So this is what contents under pressure looks like. So you can see that we have our employee, Emily, who you've already met whenever Dan Anastasio was talking about her. You can see that it's raining. We're on day 13 of a 15-day trial for the game. So the hurricane is bearing down and tensions are running a little high. And you can't hear it, but if you could, you would hear the rain in the background. You would hear that thunder from the lightning that you just saw. It's a very intense sort of environment. And it's interesting because this adds to that pre-authentication aspect where it increases the thunder, and if a siren goes off, it increases the anxiety of the person who's making the decision, and it really places you in that sort of mindset. So here's Emily, and she says she doesn't feel comfortable with this project and it's in unfamiliar equipment, which makes sense since she's new. So we can say that we'll have Victor give her some help. Or we can say, I don't have the time to help you, I'm sure you can figure it out. What makes this a little tricky, and I'd like for you as we go through these decisions, those of you who are watching here, I'd like for you to think about the decision you would make in this situation. So this is a new person. Do we say, I don't have the time to help you out? We can look up here at the top and we can see we have our time. We're at about the midpoint for safety. We're not doing very well in our personal relationships, and we're at about the midpoint for productivity. I don't think this is a really good response for a number of reasons. I mean, one, I'd like to help Emily, but then also I am concerned about how that might affect personal relationships. But then also for having Victor give her some help, the problem with that is that if you've been playing the game to this point, you know that Victor and Emily don't get along very well. So this is just another thing that we have to be concerned about. So I'm going to go ahead and say, though, even though this might cause a problem, I want Victor to give her some help. And so, you know, the prompt here, this is one of our reflection prompts, employees can get hurt operating unfamiliar equipment. Is this relevant? I think for that particular thing, that's something I was concerned about. That's why I want Victor to help her. So that's very relevant for me. And you can see our meters change. Now here's Victor talking to us. And he's stressed about this storm. I totally get it, Victor. So there's not a lot we can do about it. Or we have as many people as we can. We just need to keep working. I think that's the message I want to give my employees. It's let's just keep our nose to the grindstone. And now sirens are going off. If you could hear the audio, it would be very, very loud sirens. And why? Oh no, Emily's gotten hurt. That is really a shame because we just thought about whether she might not be a great choice for working on that equipment or not. So that looks serious. I'll get some help right away, or I'll help you myself. First of all, let's make sure that we call for help. So we call for help and we're going to sit with Emily. So now we have to be concerned about Emily. These sorts of prompts that we get are one of those things that just increase the anxiety and make it feel like you're really there. Here's our boss, and she is not happy about Emily, and rightfully so. Emily got hurt and it was on our watch. So giving her as much time as she needs, we can't afford to lose her. And by following protocol, I think that following protocol is the one that I'm most concerned about. So that's what I'm going to tell our boss. And great. So this counts as a failure. So our unit's output slowed to a crawl, and that counts as a big negative on the points that we got. And it's because I wasn't paying enough attention to the meter up here. Maybe I should have made a different decision in order to avoid that failure. So that's not great. And now Emily's saying it still hurts. She doesn't know how much she'll be able to do. And this seems a bit cold. You could still do desk work, right? I don't know if I want to say that to her. Once the storm breaks, you should head home. And if you'll notice, when I hover over this one about doing desk work, you can see that at the top, the meter for personal relationships is flashing. I don't know whether that means it's going to go up or down, but I know it means it's going to change, and I can't afford that. So I'm going to say she should go home once the storm breaks. And poor Emily, she's not feeling great. That is such a shame, and it might keep me up at night. Somebody got hurt on my watch. That's really a shame. And now here's our safety supervisor, and he wants to know if we've submitted the proper paperwork yet. So I hope you can see that there's a lot of stuff that students are going to have to deal with, things that you don't really teach in classes, and things they're going to have to wrestle with that they may have not been concerned about before. And what we really want to do with Contents Under Pressure is we want to give them the opportunity to wrestle with these decisions. We're not necessarily trying to tell them you're right or you're wrong or anything like that. A big part of this is being able to have them wrestle with the decisions and get this practice that they frankly can't get anywhere else in the curriculum until they get to their actual private sector job. So speaking of students and how they interact with the game, I'm going to go ahead and give it back to Dan Berkey, and he's going to talk a little bit more about that. So I'm going to stop this share, and we will get back to the presentation. Okay, and it should.
All right, thanks, Matt. So we're going to go through and talk about some of the student perspectives, anecdotally, that we've gotten from things that we've talked about with students after the game. So the first is, go ahead and next slide. As you could see, the interesting thing, or one of the things that we're most excited about with Contents Under Pressure is, as Matt said, lots of things are happening simultaneously, right? Which is often the case in a crisis or an emergency situation, right? There's lots of different things that are happening simultaneously that you as a person in that scenario would have to react to in real time. It's very different from reading that on a case study, for example. So this really gets at that authentic playing field, or that authentic pre-preparation that students need to gain experience with this. In surveying students, right, one of the things that really comes out year after year when we do this is that students really make an emotional connection to the characters. And that's really interesting because, as you can see, these are 8-bit characters, right? They're sort of retro style. And it's interesting because in order to make an authentic simulation, it doesn't have to be virtual reality. It doesn't have to be a completely high fidelity replication of actual reality, right? A simple 2-dimensional game like this with sort of 8-bit retro styles can really get students to connect and believe that they're in these scenarios, and connect emotionally with these characters, right? So students will get frustrated with Darwin coming and asking them and sort of being on their back. They'll get frustrated with the bickering between Emily and Victor. We've had a lot of students say, gosh, I really wish there was a button where I could fire people from these different roles. So students really get caught up in and making connections to these characters, which happens in real life, right? You get connected into the group that you're making decisions with. Students felt stressed over the decisions being made. You can see that, when the lights start flashing and the klaxons start blaring, and your daughter is calling and Darwin's coming in and Wanda's asking you what you're doing and Emily is hurt. Students they feel sometimes overwhelmed, right? And those actual constraints and those real world sort of multiple things happening simultaneously can cause stress in the students. And they talk about that. And that is a much more authentic presentation of decision making in some ways than, again, like we talked about, a paper instrument or a case study. And finally, students really find this environment to be engaging and unique. When we talk about this with students, they often find it very memorable because, again, they haven't played a lot of games or digital games in their educational experience. So they really find this to be an interesting and different way of presenting material than they've had in previous coursework. And they really believe that environment emphasizes the difficulty in balancing those personal and work tasks. So you can see a lot of things happening with students, and it's not happening in the game. And it's not just them balancing the different people at work. As Dan mentioned earlier, they also have, a family member. And so they're also wrestling with this work-life balance aspect as well. So all in all, our intention with the game was really to try and create as authentic an environment as possible to give students this practice field of making decisions in sometimes chaotic situations. So I think next up, I'm going to turn it over to Cheryl to talk about some of our research results with the game.
Thank you very much, Dan. So we're going to start by talking about student motivation towards the game. And we did a study where we actually looked at 193 different students across 4 different higher ed institutions to see how they responded in order to engage with the game. As you can see here, this is our gender demographics and our ethnicity breakdown for the individuals that were involved in this particular study. Key things that I want to point out is that we actually asked the students how much involvement they had in terms of gameplay prior to engaging in contents under pressure. And you can see that we have quite the span from those individuals that consider themselves to be non-gamers, all those to individuals who played games for 15 plus years. And then you can also see the range of how many times they typically engage in digital games on a weekly basis. And this provides additional insight as to how it might have impacted their motivation. Next slide. So we measured academic motivation because it had really strong alignment with how individuals engage in game-based environments. The academic motivation scale was developed by Brett Jones, and it's called the music model, and it has 5 different constructs. So the first is empowerment, where it's looking at a student's understanding of their belief to have control over their learning environment, so their ability to make choices and decisions about what they learn. The second construct is usefulness, and it looks at whether the student feels that the activity that they're engaging in is beneficial in terms of the long-term goals they have for their career. Success, which is the third construct, looks at whether if the student engages and puts in adequate effort, they believe that that effort is going to pay off with a successful outcome. The fourth construct is interest. So do the students actually find the content that they're learning about interesting and relevant to themselves? And then the fifth one is caring, where it looks at the environment that's provided to the students and does it help them in supporting them attaining their final goals. And on the right-hand side, you can see an example of some of the prompts that are associated with this particular instrument. Next slide, Matt. So these are the results that we obtained. We did a pre-post analysis for this particular implementation. And so the students completed the pre-survey at the start of the semester before they engaged in contents under pressure, and then the post-survey was done at the completion of the semester. And what I'd like to call your attention to is if you look at the averages for each of the constructs, you can see that they increased post-survey except for usefulness, which remained approximately the same. And there was also a statistically significant change across all of those constructs, again, except for usefulness. And we saw that when we looked at the Cohen's d, which measures the practical statistical significance, we saw that there was a small effect size associated with this. So basically what the end goal of this result is saying is that we are finding that students find engaging in contents under pressure beneficial to their motivation to engage in the curriculum. Next slide, Matt. The other aspect of research that we have looked at is students' moral reasoning, in line with what Dan Berkey introduced you with Kohlberg's moral development theory. Next slide. And so with this particular study, we ended up doing a paired data set where we were only looking at students who both did the EPSRI instrument, which I will introduce to you shortly, and then also played through contents under pressure. And in the EPSRI and contents under pressure, there are prompts in both of those that relate back to that moral development theory. So pre-conventional, conventional, and post-conventional. And so we could do a direct comparison between the two. Next slide, Matt. So the EPSRI is also known as the Engineering Process Safety Research Instrument, and we developed it off of the Defining Issues Test 2, which was a survey instrument that was developed around Kohlberg's moral development theory, but more on a general ethics spectrum. So that was looking at scenarios about if you were to steal groceries, let's see, from a particular grocery store. We took that same alignment in terms of how the instrument was laid out. So you'll see there's decision prompts, there's a choice that the students need to make, and then there's a series of considerations that follow. And so we use that same structure and the scoring approach of the Defining Issues Test 2, and then just replace the scenarios with process safety focused scenarios. Again, verifying with industry and academic experts that the scenarios we were coming up with were reflective of the process safety industry. When you look at the considerations that are at the bottom of the EPSRI instrument, they do map back directly to the pre-conventional, conventional, and post-conventional lines of reasoning. So that allows us to make our comparison with those reflection prompts that existed in contents under pressure. We also, although the EPSRI consists of 5 different scenarios, we only use the scenario that related back to the same situation that was being used in contents under pressure. So we were looking at the hurricane-related scenario. Next slide, Matt. And so what we found in our results was that the students that played through contents under pressure actually saw a shift in terms of their moral reasoning away from post-conventional and more into the conventional and pre-conventional space. And this might be surprising. Many chemical engineering educators might be going, but no, we want them to be more post-conventional in terms of their reasoning. And yes, ideally, we want to shift in that direction as we're moving them through instruction, but research that has been done on the defining issues test 2 has actually shown that most individuals in that higher education level use conventional reasoning more than they use post-conventional reasoning. So what we feel is happening in this particular situation is that we are getting more realistic understanding of how students are applying moral reasoning in their choices and decisions with the contents under pressure than we would be with the EPSRI. And this relates back to what was shared by both Matt and Dan Berkey earlier when they were talking about when you're in the environment where you're in a class and you're doing a case study, you know that it's focused on safety, you know that it's focused on ethics. And so you might have this prescribed understanding that I need to make the most safe decision, or because this is an ethical construct, I'm going to make this choice because I know it's more ethical than this choice. Whereas in contents under pressure, because you get immersed in the situation and you have different stressors that are placed on you, you're actually behaving as you would in a professional practice environment. And what we want to advocate for here is we're not saying that our game is going to move individuals or it should require individuals to go to a certain type of moral reasoning. What we like to use the game for is a tool to provide to students an understanding of where they are in terms of moral reasoning so that they can be more reflective on their choices as they enter into professional practice. Next slide, Matt. So just to summarize our presentation, we believe that contents under pressure provides an authentic, immersive environment for process safety judgments. It's been shown to not only engage students by allowing them to connect with the characters that are part of the game, involving their emotions. It helps with the demonstration of work-life balance when you have your adopted daughter calling in and saying, like, my piano recital is coming up, I really want you to be there. That's much more pulling on your heartstrings than if you just see that written on a piece of paper. Like, you actually feel that connection, and it makes it a little bit more tangible that it might not be easy to stay at work if you know that you have demands on yourself from your family. It's also been shown to increase student academic motivation to engage, and we believe that it provides an opportunity to observe non-predictive behaviors of the students. So it actually allows us to see their approach that they would take to reasoning through these types of judgments if they were in professional practice. Next slide, Matt. We would just like to acknowledge funding that we've received from the National Science Foundation Improving Undergraduate STEM Education Program, from Filament Games, who are our game collaborators that helped on this design, as well as a number of graduate students who've been involved in the research. If you are interested in using contents under pressure for your class or organization, here is the website that you can go to, or you can scan the QR code and just go to the Contact Us tab on that website. And we look forward to engaging with you and answering any questions you may have. Thank you.
Okay, fantastic presentation. And I had just typed in the URL when you were when you were presenting and opened it up. It worked great on my web browser. So I look forward to exploring that a little bit more. We have a little bit of time for some questions and answers here. And I just have one to start with. I'm just thinking about the ABET accreditation. A lot of chemical engineering programs, they're very focused on some of the ABET outcome assessments. And it seems like this case study kind of, I was looking through it and, ability to provide solutions that meet considerations of public health, safety, welfare, as well as global, cultural, societal, environmental, economic factors. I think this is one of the first assignments I've seen that really dives into, the ethics and kind of the metacognition of the ethical process. I was just going to ask a question about that. First of all, do you see this particular exercise as helping to meet an ABET, for one of the courses, for example, for safety or something like that, kind of these broader views, and if so, how? I'm guessing, what kind of experience have you had with that already?
Well, I'll go ahead and field that one, John. So I should say I am a ABET PEV, so I'm one of those guys. So I don't represent them with the comments I'm going to make, though. I'm sure ABET would appreciate me making that very clear. But the safety criterion related to chemical engineering programs for ABET is curricular based. So safety needs to appear in the curriculum, right? This is something that I personally use in our department. So I run ABET for our department and all of our assessment as well. That's one of the things you get to do whenever you're an ABET PEV. We use it to complement our existing safety instruction. And so it's really great for that purpose to be able to indicate in an ABET report that, here's our kind of traditional process safety education on proven process safety strategies such as HAZOP and management of change and what if analyses and all those types of things. But then we're not just stopping there. We're going a little bit further, and we're trying to strengthen students' appreciation for process safety and all the challenges that are associated with it by giving them this practice in making process safety decisions in a virtual environment. So it helps to strengthen your case as far as from an ABET perspective.
Fantastic. Great. And just another question. I was wondering about the feedback you've heard. I imagine you're using it for some of your courses, and as you've given this out to others and others have started adopting it, what's some of the feedback that you've heard? Do people want to adapt it to different scenarios? What can you give us some idea about how people are using it and some of the feedback you've gotten?
I can give one example. So we've had a number of different institutions that have gone ahead and used contents under pressure and in a variety of different contexts, which I think is interesting. So we've had a lot of senior design programs that are in the chemical engineering space have wanted to use it, but we've also had classes that are up to like first year engineering. So thinking about how we could introduce students to the idea of what is engineering practice, what are some of the choices or judgments you might not have to make. No one has come back to us and asked for changes to the game per se. They've just had requests in terms of different ways you could use the game within the classroom context. So I know Daniel Anastasio and Matt Cooper and Dan Berkey, when they were running it in their specific classes, they would assign it as homework because it does involve quite a bit of time. If you were to play through our single playthrough version of the game, that's about 2 hours of direct gameplay. Most of the time with students, though, we try to give them the 15-day game version, which is the 5 to 7 minutes of gameplay across that 15-day time span. And then the instructors would give them 30 days to complete 15 days of gameplay. So it's like double the amount of time of what they would need. Now, the other measures that we've talked about in terms of how you could implement in your class, one of which has been used at Bucknell University, was you actually do a playthrough of a certain number of scenarios with your students as like crowdsourcing. So you choose like a more intensive portion of the game, and then you would actually have the students making the decisions in live time as part of teams, and you'd have them reflect on the choices and how that might come to pass. You could also have them do it as more of like an individualized reflection activity if you can dedicate a full class period in order to do that. So we've been working on trying to come up with a variety of different ways to implement it in your classroom, from the completely external to the class environment as homework to like the more integrated facilitation on the side as the instructor helps guide them through the discussion process.
Okay, very interesting. Well, thank you for that. All right, I'll open it up. If anybody would like to make a comment in the chat, or you can unmute your microphone as well. There's an opportunity to do that.
I'd like to ask one question, John. Now, this is kind of an interesting approach, at least to me, because I worked in industry for 30 years, so I know how important is safety. So the question that I have for the panelists is that, do you guys do that? You have like a safety course in the chemical engineering curriculum where you include that? Or it's part of, let's say, process control or the process design courses? How is it structured in your departments? That's my one question. And the second question is that, is this process configurable? For instance, can I add my own scenarios if I want to put this in front of my students? Or it is like fixed by you guys? So those are my questions.
So I can take a stab at that. So I think most of us here, or many of us here, have been using it in. I know Matt has used it in senior design that he teaches. I also teach senior design at University of Connecticut, and so that's where I've used it. Dan, where have you used it?
So we've used it in our dedicated safety class, but
Yeah.
we have a 1 credit sort of ethics decision-making seminar about professional practice. So now we're using it as part of that.
So I think
Yeah.
we've largely seen it used in senior design courses. I haven't seen it. I don't know if anyone has asked to use it in a process control course, but like process safety and process design are sort of the two largest places where it's being used currently. With regard to it being a modifiable scenario, I mean, one of the advantages of it being a digital game is that, yes, theoretically that's possible in its current incarnation. It's I would call it sort of a beta level game. Filament Games did a wonderful job sort of developing for us as a proof of concept. In the first part of the grant, we're actively working on follow-up grants to sort of extend the capabilities of the game in the future. But right now, the scenario as it is written is the one that we sort of took from the headlines when we developed the game a few years ago, which was, again, this major hurricane, basically impacting a chemical facility in the southern United States. And so this was based on a real scenario. And the game is sort of fixed around that scenario. So I don't know if anyone else on the team has anything to add to that, but that's sort of where we are with it.
But then part of the design and control courses primarily.
Yeah, mostly design courses or process safety courses. But as Cheryl pointed out, there's been interest. We've had some interest from high schools. We've had some interest from industry. We've had some interest from folks outside of chemical engineering. We've had some folks interested in using it with first-year students. So as word about the game has sort of percolated out from this sort of community, I think there's broader interest in using it in a variety of different scenarios for a lot of reasons. One, because I think game-based learning is appealing to students. I think they like it, and I think that there's been a lot of focus on good decision making, helping students make better decisions, realizing that engineering is a very ethically driven profession in terms of the societal impacts. And as Matt talked about, a lot of that ties back to ABET. So I think when people see novel or interesting ways to try and get these concepts across to students, I think this kind of application, gets some attention then.
Is there anything in ABET about safety in undergraduate curriculum? There is?
Yeah, I'll let Matt field that one. Yeah, there's a fairly large requirement for the chemical engineering programs.
Yeah, so some years ago, after the T2 Industries disaster, which is one of the ones that we highlighted on, I believe, the second slide of the presentation, AICHE petitioned ABET to include a process safety education as a requirement for all chemical engineering programs. Now, that's specific to chemical engineering programs. I don't believe, and I'm not as well versed in the ABET program specific criteria for other engineering disciplines, but I know for chemical it is required to have process safety education as part of the curriculum in an undergraduate chemical engineering education.
I see. I wasn't aware of that, because at least at UIC we don't have a course on safety. I teach a few things in process control, primarily the onion layer approach, where you go from the basic process control system all the way up to community involvement. And we do HAZOP studies in process design, but that's about it.
Well, there are many strategies to be able to include process safety education in the curriculum. It does not have to be in a dedicated course. Okay. What you're describing that you do, and I believe you said your process control course, was it control?
Yeah.
That is that would be one way to address process safety in that particular course. And so maybe it's not limited to that course. Perhaps they also do that in transport courses, or often you'll see it in a reactor design course where they're sizing, for instance, pressure relief valves on a reactor or something similar, right?
Yeah, and one of the things I really like about this scenario is some of the people factors. Sometimes in engineering, we think of just equipment or, pressures, temperatures, things like that. But it looks like you guys have done a very good job of, even bringing up, mental health or injuries or,
Yeah.
people having personality conflicts with others on the team and teamwork. And so I think those are, just really critical elements. Like Michael, I worked in industry and we automated one of the polymer plants and we did everything, startup, shutdown, operations, did a full automation. And I came in during off hours one time and the operator was asleep at the bench. And I woke him up and he was apologized profusely. That was so unprofessional. I shouldn't have done that. And then I said, in all of this, I forgot to do one thing, and that's hook electrodes up to your chair to get your attention when I when I need it. So I hadn't thought about some of the kind of the people factors in that automation that it would make them less engaged and potentially introduce additional safety factors because they need to be able to handle the off conditions that the automation solution cannot handle. And does that make them less capable because they're less engaged in controlling the process? So I think you've done a great job with this case study of bringing up, technical but also non-technical people issues in the safety considerations for this.
And
So
John, I can just highlight some other research that we've done on contents under pressure has actually looked at that relationship piece, and we've seen that students do discount relationships as having a factor in terms of their process safety judgments, but when they play through contents under pressure, they are prioritizing relationships. So then giving them that viewpoint and allowing them to reflect on that, they then start to see the value of the relationships I have with people matter, and they are influencing the choices I'm making.
that's
I was
fantastic.
wondering, this approach that you guys are developing, which I think is really neat, if you have any plans in the future, let's say through a grant, to extend it to courses that are quantitative in nature. Safety tends to be a little bit qualitative, but let's say in reactor design, where you have to give some numerical answers and things like this. You have any thoughts on that? Because I think it's a really nice way to engage the students, which, as we know, is kind of a difficult subject nowadays. But you have any thoughts of extending your approach to more core courses in chemical engineering?
I'll go ahead and try to field that one. So
Yeah.
I think that is a really cool idea. And I think that I'll be very frank, we have lots and lots of ideas of all the things that we want to do if we had money to do them. So that's a really interesting idea, one that we will, certainly be considering in the future. And we have lots and lots of ideas that we can do because kind of like you said, it's a really interesting platform to be able to
Yeah.
engage students.
Yeah.
And so it doesn't have to be limited only to our focus on process safety decision making. We can also incorporate more quantitative type engineering parts of the judgment as well. In addition to these more softer, fuzzier human factor sort of things, we can also incorporate other things. So I think that's a terrific idea.
Okay. Well, fantastic. Excellent discussion and comments. I really appreciate the presentation today. Again, congratulations to the four of you on the Himmelblau Award. It's well deserved, and you guys are having an impact with these scenarios that you put out there for the broader educational community. And really appreciate it. So thank you so much for your presentation, and I'll go ahead and stop the recording now.